Welcome to the celebrated High Achievers Mentorship Program CHAMP. We're bringing academic dreams to reality. So in this video, I'll be making a quick revision on electrochemistry. So it will be on just the theoretical aspect. If you're having problem with the calculation aspect, you can check out our other video that we made on electrolysis calculation. So, but here we'll just be talking on electrolysis as a whole, then electrochemical cell, standard reduction and oxidation potential, and every other thing like that. So let's get started. What's electrochemistry? From the word, it deals with two types of energy: the interconversion of electrical energy and chemical energy. So now, what do we use for the conversion of energy? Energy is being converted. Chemical energy is converted to electrical energy. Electrical energy is converted to chemical energy using what? Using cell. So you use cell for the conversion of energy. Now we have two types of cell. Two types of cell. We have the cell that is used for the conversion of what? Electric energy to chemical energy. That's what we call what? An electrolytic cell. Electrolytic cell. Then we have a cell that is used for the conversion of chemical energy to electrical energy. That is what we call what? An electrochemical cell. So take note of that. So these are the two types of cells that we have: electrolytic cell and electrochemical cell. Now let's move on. Now we have two types of conduction. We have electronic conduction and electrolytic conduction. Let me start with this electrolytic conduction. But before I explain the two types of conduction that we have, let me just try to differentiate between these two types of cell. Now this is an electrolytic cell. You have your anode, you have your cathode, you have your electrolyte. Then yes, so this is an electrolytic cell. Then this is an electrochemical cell. Electrochemical cell have two container. Anode will be in one, no, the positive here, or it's cathode, then the negative here. Yes, then it will have two different electrolytes. Then there is something that will link it, which is what we call the salt bridge. It will link the two electrolytes together. This is wire current. Yeah, so let's move now. This is an electrochemical cell. So if you're asked to differentiate between an electrolytic cell and an electrochemical cell, what do you say? You know, here you have what? You have positive, you have negative, positive, negative. In an electrolytic cell, the anode is what? The anode is positive. The anode is positive. The cathode is what? The cathode is negative. While in this place, the cathode is what? The cathode is positive. And the what? The anode is negative. Do you get it now? Now, another thing that you need to notice is that this one have how many electrolytes? One electrolyte. Then this one have how many electrolytes? Two electrolytes. Then this one have a salt bridge. But this one what? This one does not have a salt bridge. Yes, another difference between them is that this one is not spontaneous. It is not spontaneous. It uses an AC circuit. But this one is what? Is spontaneous. It uses a what? Direct current circuit. Yeah. What another thing that we know from the definition: electrolytic cell is used for the conversion of what? Electrical energy to chemical energy. Why this one is used for the what? The conversion of chemical energy to electrical energy. So yes, these are the major differences between an electrolytic cell and then this one have one container, while this one have what? Two container or two compartments. Anyone? Yeah. So that's the basic difference between an electrolytic cell and an electrochemical cell. Let's move on now. So I'm talking on the types of conduction. I said we have electronic conduction, and we have what? Electrolytic conduction. So let me start with electronic conduction. Electronic conduction is a type of conduction where we have rods, metals, and wires are conducting electric current using what? Using free mobile electrons. Never forget this: free mobile electrons. They use free mobile electrons. Yes, so that's for electronic conduction. Now, electronic conductors are usually what? All metals are conductors of electricity. Then graphite. Graphite is the only non-metal. It's the only non-metal that conduct electricity. So take note of that. Take note of that. Yeah, let's move on now. So we have electrolytic conduction too. Electrolytic conduction. Electrolytic conduction is when electrolytes conduct electric currents using what? Using hydrated ions. Hydrated ions. Yes, we have or you can say free mobile ions, but hydrated ions is actually best because the ions must decompose. Now let's quickly check the difference between conductors and ions and electrolytes. Now conductors are always what? Always solids. Now electrolytes can be in the molten form or aqueous form. Aqueous form. Then yes, conductors are not decomposed. They are not decomposed during the process. But electrolytes must be what? Must be decomposed. They must be decomposed during the process. Then this one use what? Free mobile electrons. Why this one use what? Free mobile or hydrated ions. Now we have two types of electrolytes. We have the strong electrolytes and the weak electrolytes. Just like your strong acid and weak acid and strong base. Strong electrolytes are electrolytes that ionize completely. Example are strong acid like HCl, like H2SO4, like HNO3. They are what? They are strong acid. Then we have what? Strong bases. The example of strong electrolytes like NaOH, like QH, and their salts. So like NaCl, KCl, K2SO4, they are strong electrolytes. Why weak electrolytes are electrolytes that what? Ionize partially. Electrolytes that ionize partially. They ionize partially. Example are organic acids. All organic acids are weak. What are the examples of organic acids? We have what? We have HCOOH, methanoic acid. We have CH3COOH, ethanoic acid. This one is methanoic, this one is ethanoic. We have oxalic acid, COOH. And other category of the example of weak base of weak electrolytes are weak bases. Like what? Like ammonia. Then you have the sort of organic acid or sort of weak bases like sodium, ethanoate, and all of that. Now, if something cannot conduct electricity at all, maybe using free mobile electrons or hydrated ions, we call that thing a non-conductor. Or an insulator or a non-electrolyte. Yeah. So this one is about example are ethanol. Ethanol will never conduct. Then we have what? We have kerosene. We have what else? And all of that. They are what? They are non-conductors. They are non-conductors of electricity. Now, the conductivity of electrolyte depends on three things. Conductivity of electrolytes depends on three things. Let me just chip this in. Number one, it depends on the what? On the concentration. Number two, it depends on the what? On the temperature. Then number three, it depends on the nature. Yes, let me just take them one after the other. So we have the concentration. The higher the concentration, the what? The lower. The third one is nature. The what? The lower is inversely proportional to conductivity. Now, if a solid, if a compound is very concentrated, the conductivity will be what? The conductivity will be low. And what's the reason? The reason is because the meaning of concentrated is that water is not enough. So acid is more than the water, or the base is more than the water. So water is what is responsible. Water is what is responsible for the conduction of electricity in aqueous solution. So water is responsible. So if that water is lacking, then the conductivity of the electrolyte will be low. So that's just the principle. If it is very concentrated, so I can say dilute electrolytes will conduct more than concentrated electrolytes. Dilute will conduct more than the same. Okay, yes. Now temperature is direct. The higher the temperature, the higher the conductivity. the higher the temperature, the higher the conductivity. So an electrolyte at 50 degrees Celsius will conduct more than an electrolyte at what? At 30 degrees Celsius. Then the nature is talking about if it is strong or weak. A strong electrolyte will always what? Will always conduct more than weak electrolyte. What's the reason? Because it was ionized completely. It will give a lot of ions that can conduct. So yes, I'm sure you know the one that will conduct most between what? Dilute acid and what? And concentrated acid now. And the one that can conduct most between strong acid and what? And weak acid now. So which one will conduct most? Dilute or concentrated acid? That's what dilute. Which one will conduct most? Strong or weak? That's what strong. So take note of that. Strong acid conducts more than weak acid because they are ionized completely, but dilute conducts more than concentrated because they have high water content than concentrated H2SO4. Yeah. So let's move on now. So I'll be talking on the Arrhenius theory now. Arrhenius theory. Now, Arrhenius theory is postulated by Arrhenius in 1766, or is it 1776? Yeah. Now, before I move fully into Arrhenius theory, let me talk on electrodes. Now, electrodes are present in the electrolytes for the what? For the conduction and passage of electric currents and electrons. This is the function of the electrodes. Now we have two types of electrodes. We have two electrodes. We have anode and what? And cathode. We have anode and we have the what? Cathode. Now, what is the anode? The anode is the what? Is the positive electrode. I'm dealing with electrolysis now. It's the positive electrode. Now, this anode, which is the positive electrode. Okay, before I move on, cathode is the what? Is the negative electrode. Now, which reaction happens at the anode? We call it what? Oxidation. Oxidation reaction occurs at the anode. Then reduction reactions occur at the what? Occur at the cathode. So we call it CREO. Cathode is reduction. Then anode is what? Anode is oxidation. Cathode is reduction. Anode is oxidation. Now, let me go a step further. This one is what? Oxidation. What's the meaning of oxidation? Leoja. Loss of electron is what? Oxidation. Gain of electron is what? Reduction. Leoja. Now, loss of electron is oxidation. So what is the meaning of this one? Loss of electron. So that means electron leaves the cell. Loss of electron through what? Through the anode. Electron leaves the cell through the anode. Are you getting it now? Now, the same thing for, let's check for cathode reduction. Reduction is what? Gaining of electron. What's the meaning of gaining of electron? That means electron is entering the shell at the what? At the cathode. Electron enters the cell through the what? Through the cathode. Yes. So that's just that. Now, the direction of electron and the direction of what? Currents. They are what? They are opposite. So if electron goes this way, current will do what? Current will go this way. If electron goes this way, current will go this way. Now let's come back to this. Electron leaves the cell through what? Anode. That means current will enter the cell. Current enters through what? Through anode. Because the anode, the current and the what? Electron, they are opposite. So if electron leaves the cell through anode, current will do what? Will enter through the anode. Then this place, electron enters and what? Current leaves. Electron enter and current leaves. The electron enters the current and current leaves through the what? Through the cathode. Let's take note of that. Let's move on now.